Good afternoon, everyone. Thank you for joining us today for the Lincoln Agritech Beyond Number 8 webinar session. My name is Joanna Lee, and I am the Marketing and Events Coordinator at Lincoln Agritech. I handle event organizations and coordination, and I work closely with my manager, Ashley, on Lincoln Agritech general marketing efforts. Before we begin, please note that this webinar is being recorded. By default, your camera and microphones are disabled, but feel free to enable them during the Q&A session at the end. You can also type your questions in the chat box, which is at the top of your screen, at any time during the presentation, and we will address them one by one afterward. Our Beyond Number 8 series aims to share agri-tech knowledge and insights with the primary sector. We launched it in 2022 as a podcast, and now we are expanding it to include webinars. A couple of weeks ago, we hosted our first webinar, Unleashing the Power of Data Science. I have shared links in the chat box, so please feel free to explore them later. Today, we are excited to present our second webinar, Transforming Yield Maps into Profit and Loss Maps. This is a fascinating topic. Do you want to know which areas of your products are the most profitable? Do you want to increase the yield through the smart farming and better management? Our speaker today is Allister Holmes, a precision agriculture agronomist at Lincoln Agritech. Allister has many years of experience using his research findings to deliver practical and beneficial outcomes for growers. He will be explaining his latest research findings with us today. All right, let's welcome Allister.
Thank you, Joanna. Can you see my slides are preparing at the moment? Okay, so can you see my slides?
Yeah, I can see. Yeah.
Great. Okay. Well, thanks for joining us today. So I've just tweaked the title of this presentation a little bit. I've tweaked it from transforming yield maps into profit and loss maps, into transforming yield maps into productivity maps. So basically, with the yield data that we're recording, we're able to prepare a series of different maps, and I'll show you some of those. And I guess the key thing about this presentation is what my interest is how do we get practical insights rather than just drawing pretty pictures, displaying data. What can be changed on the farm to improve profitability, reduce risk, and reduce environmental impact? So yeah, like Joanna said, if there's any questions, perhaps put your hand up. I can probably see your hand if you raise your hand, or put them in the chat box, and we can talk about them towards the end of the presentation. Okay, to start off, if I can move, agriculture, as we all know, agriculture is variable, and this is a good photo. It's actually a photo of the Foundation for Arable Research Northern Crop Research Site south of Hamilton in the Waikato. It's taken in March one year, and you can see that entire area is growing maize, and you can see the difference in the crop maturity and the difference in the color of the leaves of the maize. So we know that agriculture is variable. So I guess the question we have to ask is why is agriculture variable? And some of the reasons why agriculture are variable are inherent in the site. Especially with pastoral and arable horticulture, we're dealing with large areas. So there is variations in the soil types in the paddock, soil texture, the soil depth, particularly in Canterbury. The depth of topsoil varies widely. The difference in the water holding capacity. of the soil, and then there are other variability issues in that paddock. So it might be the slope. On slope country, the slope can affect the amount of water that stays in the paddock, the drainage, the waterlogging, tree shading, particularly where I'm from, the Bay of Plenty. Shelter belts are a major issue, so you can get a lot of field variability from trees. And these are just the variability that's inherent in that site. Then we put on a layer of management over the top of that, and we can actually increase variability over time by using synthetic fertilizers. We can decrease the pH of soil, increase the acidity of soil over time. We can change the nutrient status of soil depending on where we put fertilizer, and if we don't apply fertilizer uniformly, we can result in compaction in paddocks. And I think most people are aware of paddocks where there's compaction, say around the gateways where machinery travels through, or in the headlands of cropping paddocks, and also field history. So when I used to be involved with cropping in Gisborne, sometimes if we had a very wet harvest season, we'd have a lot of paddocks that would be compacted because the clay was harvested in the wet. So over time, these build up variability in the site. So what we're lucky with is that we've actually got the way to measure this variability for probably 30 odd years now. Harvesters have had yield monitors. So effectively, as they're harvesting the paddock, they are recording a GPS location, but they're also recording a yield value for that location. So on the left here, we've got a combine harvester harvesting a crop, and every second or maybe 2 seconds, it's recording its GPS location, a mass of the grain that it's harvesting or is traveling through the harvester, and often other parameters such as grain moisture, grain protein, and other parameters. And on the right here, we've got a potato harvester, which is doing very similar. So every second, it's got load cells under one of its belts, and it's recording the mass of potatoes every second as it travels through the paddock, and that can be mapped. And that just showing you for the potato harvester, effectively as the potatoes go over that belt on the right, they're being weighed every second, and a yield value is being recorded. As you can imagine, there's quite a bit of variability and inaccuracy in those data points, but because we collect so many data points, we can clean up the data and work with the averages later. Now, if we go back to that first slide I showed you, you can, as I said, agriculture is variable. I hope this is going to work. And we can actually map this variability. So there's an image that shows that original photo, and then on the right-hand side is a yield map from the grain crop that came off that paddock. And you can see, if you use your imagination a little bit, there's some alignment between the yield pattern that was recorded on the right and the image on the left. So it shows that we can record this data and we can measure this geospatial variation. So this project, the aim of this project was to source grower data from multiple years. And as I said, yield monitors have been in use in New Zealand on combine harvesters since the 90s, and a lot of data has been recorded. This data is often not stored in a very usable way, so sourcing that data and analysing it and using it has value. So the first part was to source this data from multiple years, analyse the spatial variation, so that's the variation around the paddock, the difference across different parts of the paddock, and the temporal variation. So by that, what we're saying is analyze the variation that occurs between different seasons. And so analysing the spatial variation in one season is very interesting because it shows you the difference in performance in that paddock in that season. But when you start comparing the paddock variation over multiple seasons, you start to see a bigger picture and a longer term pattern of performance in that paddock. Then we can create geospatial yield maps, we can create geospatial profit and loss maps. And then probably the most important thing is we can then say, so what? Once we have these maps, what can we do to change management decisions to increase profitability or reduce input use, leading to higher input use efficiency, and then assess the impacts on profitability. So to give you an example of this, there's a number of sample paddocks in this presentation. So in this sample paddock, this is a large paddock of potatoes in South Canterbury, and you can see the image that I've given you here is the bulk crop yield mass of potatoes, where you can see the green is the highest yield, then the yellow, then the orange, and then the red is the lowest yield. So you can see there's definitely a pattern there. We can then look at, well, what does that mean in these different colours? So we can calculate the gross margin for each point in that paddock quite simply by working out the costs of growing that crop, what the income of growing that crop is, and then we can effectively use the yield at the point to calculate a gross margin and then map that. And so when we do that, we can see that most of the paddock is in profit. The red colour shows a loss from growing the crop, and there's nothing that focuses a grower's mind as quickly as putting a red or a loss on a map and showing them that. So that just shows that most of the paddock is creating a profit, but that parts of the paddock are creating a loss. And the question from this is so what? What can we do, or how does that pattern occur? And if we understand how that pattern occurs, what can we do to change it in time? So when we did this and sat down with the grower, we said to them, well, this is the image of profit and loss. What do you think? And they said, well, actually, that makes sense, because this image shows the coverage of the center pivot irrigator. And the moment I showed them this, they said, oh, well, that makes sense, because where the paddock wasn't covered by the center pivot irrigator, they were meant to move surface pipes to irrigate it, but they missed the round of irrigation on Christmas Eve because they had other things happening, and that resulted in an impact on the yield. And in this example, the whole paddock was 17.5 hectares, and the gross margin over that whole paddock was $2,419 per hectare. But if they took the gross margin of the 13 hectares onto the centre pivot, that was $2,826 per hectare. So effectively, the centre pivot covered area of crop was producing nearly 20% more profit per hectare than the area of the paddock outside the pivot. So that's all very well, but as I always like to say, so what? What does this mean for the grower? In this case, we've got management-induced variability from the effect of irrigation. As I say, the areas of the paddock that didn't get the same amount of irrigation had a lower profit. So what could they do? Well, in those areas, they could grow a crop that's less dependent on irrigation. I ignore that next comment. That's about some other work we did there. They could grow the 13 hectares under the centre pivot in high value crops. and they could grow the remaining 4.5 hectares in a less irrigation dependent crop, which would then result in less management input. So in this specific case, the grower decided that when they grew that paddock next in potatoes, I'll go back a slide here, they would not grow the area outside the pivot in potatoes, but would either grow it in a dryland grain crop like barley, or they would just grow ryegrass hay there and harvest it alongside another crop in an adjacent paddock. Okay, so sample paddock 2 here. So looking at the other end of the country, this is in the northern Waikato. This is a paddock that grows maize grain year after year and has grown it for some time. And by looking at 7-year average of yield, we could draw this map showing the average yield per year over these 7 years. And you can see in the main rectangular part of the paddock that the yield is up over 11 tonnes, even over 12 tonnes per hectare. But there's an area down towards the uneven left-hand end of the paddock, which you can probably tell is adjacent to a small stream, which the yield is significantly lower. Okay, so what does this mean for the grower? If we map this out into profit and loss, now bear in mind, this is showing the average profit and loss over 7 years. So it's not just a one-off, it's not just an odd season where it was very dry or very wet or the pukekos got into it. This is the average profit and loss over 7 years. And in this red area here, the average year the grower lost money in that area. And when we talked to the grower about this, he said, well, that actually, it doesn't surprise me too much because that is very heavy clay soil, and I find it very hard to create a reasonable seed bed there in spring because it's cool and it's damp, and it's always a struggle to get a decent seed bed. And even if I do get a decent seed bed there, it's more prone to bird damage because of the fact that it's adjacent to a stream and the birds tend to congregate around the stream and pull the place out there. So if we look at it and say, well, what if we effectively stopped growing in that poor performing part of the paddock? What would that mean for the crop performance? So effectively put this artificial line across there and only plant the crop, only cultivate, only plant up to that line. And we can measure it and we can say, well, based on the current paddock area, the whole paddock was 7.6 hectares. The average yield was 11.4 tonnes per hectare. The average gross margin was $274 per hectare. But if we exclude, if you look to the right here where it says zone excluded, if we exclude that 1.5 hectares that's hard to grow a good crop in, that 1.5 hectares only produces an average of 9.8 tonnes per hectare, and the average gross margin in that area is a loss. So looking in the middle, the new paddock area, which is 6.1 hectares, the average yield increases because we don't have that low performing part of the paddock there. The average gross margin increases because you don't have that loss generating part of the paddock there. And what we've also got down at the bottom here is because the grower is typically applying the same amount of fertilizer across the entire paddock, the overseer calculated nitrogen losses vary depending on the yield of the crop you're growing. Because obviously if you're putting on enough fertilizer for 12 tonnes per hectare and you're growing less than 10 tonnes per hectare, there is more fertilizer not being taken up by the crop that is at risk of losses. So if you look at this bottom line, haven't updated this for a while, but Overseer FM rather calculated for the whole paddock that the nitrogen loss was 30 kilograms of N per hectare per year. But the poor performing zone that we proposed to be excluded was losing 65 kilograms of nitrogen per hectare per year, simply because the yield of the crop wasn't high enough to take up the amount of nutrient applied there. So the other thing we can do is with this long-term data is we can actually look at the coefficient of variance there. So effectively what we're saying is how consistent is the performance of that paddock over time. So the lower the CV, the more consistent that paddock is over time. And you can see in our sample paddock, the middle part is more consistent over time, and the extremities of the paddock are less consistent over time. So we all know examples of paddocks that certain parts of the paddock perform very well in wet years or very well in dry years. And those are the parts of the paddock that tend to have a high CV. That means the yield varies a lot from year to year over a number of years. And they're very hard to manage because we tend not to know, we don't know what the weather is going to do for a season until the end of the season. But before then, we've put in all the inputs accordingly. So these high CV areas that we can assess by comparing the yield over a number of years are effectively the highest risk parts of the paddock. So if we go back to here, what the grower can do in this situation is they grow adjacent paddocks to this maize paddock in oats for silage, and so they are growing this grey area here now in oats for silage or grass for hay. They use it as the headland to turn their machinery for growing maize on the rest of the paddock. By that, they reduce the risk of growing a poor performing crop. They reduce the risk of compaction to the high performing part of the paddock because they're turning on the lower performing part of the paddock, and they're increasing their gross margin by removing that part of the paddock. Okay, so the same question for the sample paddock. So what can the grower do? Can the grower do? So in this paddock, we've got inherent variability. The clay soil texture near the stream leads to compaction, and that leads to the problems with being able to create a seed bed, which leads to the problems of bird damage, so the yield's down. So what can they do? Well, they could deep rip. They could apply gypsum, but in this case, the growers decided that they will grow a lower cost crop that is less dependent on a seed bed and seedling emergence in spring. Okay, and for the last paddock here, so what we can also do is we can also look at different crops grown in the same paddock over time. And so in this third sample paddock, we're looking at 6 years of harvest yield data. 3 years are from wheat and 3 years are from maize grain. And as it says on the caption there, the wheat data is shown in the image on the left, the maize grain on the right. And not surprisingly, you can see that there is a similar trend in that yield data between the two crops. The high performing areas are the same in both crops, and the low performing areas are the same in both crops. Now, the way we deal with the fact that we are comparing different crops is we normalize the yield data. So in the case of maize, the average yield might be 12 tonnes per hectare, we normalise that and call that 100%. And then effectively anything higher than 12 tonne becomes more than 100%, and anything lower is less than 100%. And we do the same for wheat. The average yield for wheat is 100%, and then we go up or down from that. And that allows us to compare the relativity of the yield between different crops. So we're not just limited to comparing the same crop in the paddock. So in this case, we can look at over the 6 years, the whole paddock is 9.2 hectares. The normalized average yield is obviously 100% because it's a 100% is the average yield. The average gross margin is $396 per hectare. And oops, sorry, I've jumped some slides, sorry. Jump forward. Okay, sorry. So if we look at the normalized yield, 3 years of data for wheat, it shows that the difference CV, so the difference in the variability of those crops. So you can see there that the CV for wheat is the range there is much higher than for maize. So effectively what we're saying is that the wheat is more variable over 3 years yield than the maize. The standard deviation is over double, or sorry, not quite double for the wheat. So the variability of yield of wheat, it is less consistent than maize over those 3 years. And we can start breaking down, well, what are the different zones of the paddock as normalized yield? So if we look at the left-hand side there, we can say that which part, how much of the paddock performs less than 90% of average. And in this case, it's 1.9 hectares of wheat, which is 21% of the area, 1.2 hectares of maize, which is 13% of the area. So we can see from that as well that the performance of wheat is more variable than maize. And that's just interesting to know for a grower to know that probably wheat does well in a wetter year because it's got more growth potential, and they wouldn't irrigate as much as if they were growing maize. What we can also do, as we've discussed, is look at a 6-year profit and loss map. So by creating a gross margin for each data point for wheat and a gross margin for each data point for maize, we can then average those values to come up with a 6-year average. And you can see again that there is a significant amount of red ink showing there, which is a loss. And in this particular case, that is immediately adjacent to a pine forest. Often has a pine forest and a hill, so it often has water sitting in there, and it's very prone to getting compact. So the hypothesis, the idea was that again, this part of the paddock would be removed from the higher value intensive crops and would grow in a different type of crop. And by doing that, we can see that situation. We remove this 1.5 hectares of loss generating crop, which then results in the paddock reducing in size to 7.7 hectares. The yield effectively goes up by 5% because we've removed the low performing part of the paddock, and the gross margin increases by about a third. So, it goes from $396 per hectare to $530 per hectare. So it increases by quite a lot because you've reduced that poor performing part of the paddock. So for the grower here, so what? In this case, it's actually quite similar to the second paddock. They've got management-induced variability from the effect of compaction, but they've also got some inherent variability from the adjacent pine trees. What could they do? Well, they could deep rip, they could apply gypsum, or as they're doing in their case, they're growing a different crop in that area to remove the need for putting those high value inputs in there. So as a general sort of overview and summary, using profit and loss data, and maps, that should be and maps, and can improve profitability. It can reduce the workload, so it can actually reduce the area of cropping and still result in a higher yield on average. And I think this next one's a really important one, is it can decrease the risk of nutrient loss, because if you're putting on a full rate of nutrient, but the paddock is consistently producing a lower than average yield, that's a very high risk scenario for nutrient loss. And it can lead to this precision conservation idea, where you're using the data, the precision information that you've got, to start tailoring areas of the paddock that you are going to conserve effectively. You're not going to put the same inputs in. So in this case, we're talking about the productivity maps, and the productivity maps, that the data can be used for creating the profit and loss maps, which we've shown. It can also be used to generate nutrient use efficiency maps, because we can map the yield versus the fertilizer inputs or the irrigation inputs, and effectively measure the yield per kilogram of nutrient, or yield per millimeter of water, which is giving a very good indicator of input use efficiency. So the recommendations, and yet the key thing here is there's some practical steps. The first step for any of this work is to obtain the geospatial yield data for your crops. In this case, we're talking about arable and vegetable crops, but there are a lot of forage harvesters have yield monitors on them too. So we get yield maps for maize silage, we get yield maps for grass picked up for silage, and there's various other ways to do it. It's a continuing bugbear of mine that I don't think the industry values the geospatial yield data as much as I would like them to. I remember being asked to see a grower who had a almost brand new harvester, maybe $400,000 worth of harvester. It had a GPS in it, it had a yield monitor in it, but when it was supplied without a data card. So they'd been harvesting for a year and not recording any of the yield data, which is just a loss of valuable information there. Then once you've got that geospatial yield data, you can calculate the geospatial gross margins, and then you can combine and compare the profit and loss, the gross margin maps from multi-year crops, identify the areas that are consistently return losses, and then decide what to do in these areas, whether you reduce inputs, whether you grow a different crop, or whether you don't grow any crop at all. And I think the data that you've got provides a useful, a very valuable starting point to having that conversation. So I'd just like to acknowledge that the growers who are involved with this work. Matthew Gray of Unearth Ag, the ag leader dealer. The product I use for analysing the data is an ag leader product, SMS. The work was undertaken as part of a sustainable farming fund, and it was undertaken when I was at the Foundation for Arable Research. So I hope that presentation is of interest to you. Happy to have specific queries asked of me, or we're probably running out of time here, but email through, or if you've got any questions, please ask them now.
Wonderful. Thank you very much, Allister. Such an insightful presentation. I'm sure this will help the growers and farmers improve their farming profitability. Any questions?
Oops, okay, we've got a Q&A popping up here.
Yeah.
Okay. Yep, great question. how do we get the value of yield mapping across to growers increased for adoption? And so it's a frustration that the leading growers in New Zealand are as advanced as any growers in the world in the use of precision ag tools and yield mapping, but it's not got wide penetration. I think there are opportunities for organizations to work with growers to help them undertake this process. Part of the challenge is that if you're a grower and you decide you want to analyze your own yield data using a GIS software tool, it's a slow process to learn the GIS software tool. So I think there's an opportunity for industry participants to help growers undertake that analysis and then undertake the conversations at the end of the analysis as to here's the data, here's the analysis, so what do we do after that? So I think it's the challenge is that we don't really have the extension agents on farm to do that, which is a real challenge.
What's the next one? Any
Any
other
other
questions?
no other questions?
Well, I actually have some questions from myself.
Yep.
So I'm not sure. So what's other initial steps if I am a farmer, if I need to, start mapping my profit and loss, and what should I do for the, initial steps?
Yeah. Well, I think if you're a farmer who is growing a crop that is harvested with a combine harvester or a forage harvester or a tuber harvester, is to ensure that you have a GPS on your machine, a yield, a way of measuring the yield, whether it be load sensors on your machine, and that you're actually capturing that data. Because once that data's, and this is something I've said to growers for probably 10 years now, is start recording that data. Even if you don't do anything with it initially, suddenly you'll find you're 5 years down the track and you've got 5 years yield data and it has some real value. So what I would say is if you've got the opportunity to record that data, record it. Make sure that data is saved safely, and then at a later date it can be analysed to help make good decisions with it.
Yeah, good point. And also, you mentioned when using this technology or techniques when farming, we reduce the nitrate leaching to the soil. So, except the nitrate leaching, what others environmental footprint we can, optimize in, during this process?
Yeah. So we actually, while I was doing this work, I got approached by two students from University of Canterbury who were working with a onion grower near Christchurch, and they'd measured the yield by GPS mapping where the bins of onions were picked up from. And they'd worked out that the bulk of the yield was coming from an area of the paddock that had better access to irrigation than the rest. And so the following year, they grew onions in the same paddock, but they reduced the area by 30% and still grew the same amount of onions because they could put more irrigation on this area. So effectively, they've increased the water use efficiency, they've increased the yield per hectare, and almost certainly increased the profitability in that example. So nitrogen is obviously a key one because of the accountability for leaching. Water use is a key one as well, but also the cost of cultivation, the carbon emissions of cultivation. There is no point continuously cultivating, planting, spraying, fertilizing a part of the paddock that you are losing money on and also creating carbon emissions, nitrogen leaching, etc. So it's just really understanding the variation in your paddock and targeting where you're going to get the greatest return, the best bang for your buck, and the greatest return on your inputs.
Wonderful. Is there any other questions online? Okay. If there's no questions, that's probably the end of the presentation. Thank you everyone for joining us today, and also a special thanks to Allister for delivering such fantastic presentation today. We hope you found this webinar informative and that it provided you with practical knowledge to apply in your farming practices. As a reminder, the recording of this webinar will be available soon on our website and the social media channels. If you have further questions or need additional information, please reach out to us. We are always here to help and support your journey in agritech. Thank you once again for joining us. Have a great day, and we look forward to seeing you again at our next Beyond Number 8 webinar. Goodbye.
Thank you.